let's talk about Ohm's law. Ohm's law applies to all resistors, and it only applies to resistors. So it's not going to work for capacitors. But anything that has resistance, Ohm's law will work for. And the formula, pretty straightforward. We've got V, the voltage. This is the voltage drop across the resistor. I'm going to explain that in more detail in just a moment. I is the current through the resistor, and R is the resistance of the resistor. Now right here you can see this is the symbol for a resistor in a circuit diagram. So this specifically, this jagged piece, that's the resistor. These straight lines here represent the wires. So when I'm talking about V, the voltage drop across the resistor, you want to look at the points at the beginning and end of the resistor. If we look at those 2 points, we could measure the potential at each point. So let's say that the potential over here, we'll call this point A and this point B. And so I'll say that the potential at A, and I'm just going to make up a number here, is 100 volts. And I'll say that the potential at B is 95 volts. And also important to point out that the current, I'll say the current is going that direction. Okay. So what's happened here? Well, you can see that the potential was at 100, then you go through the resistor, and it's 95. It's dropped 5 volts. Okay. So if I actually calculated the change in potential, that would be negative 5 volts. Okay. So what do we say? Well, we say for the resistor then, we say the voltage drop is just 5 volts. Nobody would ever say that it was negative 5 volts. We say the voltage drop across the resistor is 5 volts. So that's what that means. And that's why we say, by the way, across the resistor, because we're talking about from the beginning to the end. And this is expected that it's a drop, because remember that the resistor transforms electrical energy into thermal energy. So we do expect the voltage to drop as the current goes through the resistor. Now let's talk a little bit about the units. Voltage is the voltage is measured in volts, of course, and the current is measured in amps, and of course resistance is ohms. So an amp times an ohm is going to give us a volt. And the last thing that I want to talk about is just the graphical behavior of Ohm's law. So let me switch colors here just to make it more obvious. Okay, so V equals IR. We can compare this to the formula for a line. Mostly in circuits, we deal with temperature-independent resistors. So that means that the resistance is going to be a constant. It's not going to change. And so that's important. When we're comparing this formula, Ohm's law, to Y equals mx plus B, if we keep the resistance constant, well, then we could see that X and I are going to go together. We can do V and Y together. And that means that M and R are going to be the same. That means the slope is going to be the resistance. So my y-axis, the y-axis can be represented with the voltage. The x-axis can represent the current. And the slope of such a plot gives me the resistance. And notice that we're not adding anything. We're just doing plus 0. So that means B, the y-intercept, should be 0. So that's something else we can see. So that means when we do these plots, if we do a plot of voltage versus current, it should start at 0, 0. It should look something like that. And the slope will equal the resistance.